Now that we've defined the inverse cosine function, let's work a couple more of these problems where we take a trig function and compose it with an inverse trig function. Let's look at the first example. Cosine of tangent inverse of negative 8 over 15. Negative 8 over 15 is not a tangent value for one of our special points on the unit circle, so we're going to have to use a triangle to determine or to evaluate this problem. Tangent inverse spits out an angle between negative pi over 2 and pi over 2. So we're going to be in the right half of the plane. In order to get a tangent value of negative 8 over 15, our triangle is going to have to be down in quadrant 4. So the tangent is negative in quadrant 4. I'm going to want the opposite leg to have length 8, the adjacent leg to have length 15. There's our rotation theta there, whatever it happens to be. But I don't need to know that rotation in order to figure out the cosine. By the Pythagorean theorem, my hypotenuse has length 17. And so the cosine of that angle is going to be 15 over 17, and it's positive, of course, because we are in the right half of the plane. Let's try the next one. Tangent of cosine inverse of 12/13. Cosine spits out an angle between 0 and pi, so we're going to use a triangle in the upper half of the plane. For cosine to have a value of positive 12/13, that triangle is going to have to be in quadrant 1. So again, we'll mark some lengths here. The adjacent 12, hypotenuse 13. There's my rotation theta, whatever it happens to be. The tangent for this given triangle, well, the Pythagorean theorem tells me that that opposite leg is going to be 5. And so the tangent of this angle is 5/12.